Wow, look at that graph. That's the graph of y equals negative x minus 2 times x plus 4. Where does this graph cross the x-axis? The x-axis is the flat one. I notice it crosses here at negative 4 and here at positive 2. Interesting. Crosses at negative 4 and positive 2. How does that relate to the original function? Negative 4. I see plus 4 over here. Okay. So like negative 4 plus 4 is 0. That's cute. Positive 2. I see minus 2. So like 2 minus 2 is 0. Oh, interesting. Where's the vertex in relation to the intercepts? So remember, our vertex is like the top or bottom point. It is the highest point or the lowest point. In this case, it's the highest point. But if you look, that's at negative 1, 9. Now the x is right in the middle of the two intercepts, the two zeros. So there we go. The x-coordinate is right in the middle. The y, I don't know. Maybe we'll find out later how to figure out that y. I don't know. Oh. Why does this graph seem wider than the first one? Well, I'll tell you. It's because of this number in front. That's our a. That shows a stretch or compression. If that number is bigger than 1, it makes the U shape way skinnier. It narrows it out. If it's between 0 and 1, it makes it wider. So that's a compression, a vertical compression. What is the domain and range of this function? Well, it's a quadratic function. So domain is your left and right limit. It goes forever to the left, forever to the right. So you could write all real numbers like the r with the line through it. You could write all real numbers. Or if you're in interval notation, we'll say negative infinity to positive infinity. Now the range is the up and down. There is a limit. It doesn't go down forever. It maxes out down here at negative 1/2. So we're going to say our range, the low end is negative 1/2 or negative 0.5. And remember, if it actually hits that number, you put it with a bracket. The upper limit, it does go on forever upward, so it'll head towards positive infinity. Delightful. Try to write the equation for this graph. How do you know what numbers and signs go where? Okay, all right. Now, I know that the zeros, the intercepts, are important. And I see that this one crosses at negative 1, and it crosses at 3. So if it crosses at negative 1, I know that's going to show up as x plus 1, because negative 1 plus 1 is 0, and we're looking for zeros. It also crosses at positive 3, so I know that's going to say x minus 3. It always looks like the opposite of what the 0 is. So if it crosses at negative 1, you'll see x plus 1. You see positive 3, x minus 3. The only other thing is like the a out in front. Now here's what I'll show you about parabolas. And maybe we've talked about this before. The vertex, when a is 1, that means it just goes up 1 over 1 in both directions to the next point. And then it goes up 3 over 1, 5 over 1. This one does not. This one goes up 2 before it goes over 1. So in that case, that means there's going to be a vertical stretch of 2. So there's going to be a 2 in front. What's the domain and range of this function? Domain for all these quadratic equations is all real numbers. There is a range, though. Now, the lowest this one ever goes is negative 8. So that's the lowest it hits vertically. And it actually hits negative 8, so you got to put the bracket there. And it goes forever upwards towards positive infinity. Fantastic. Unbelievable. Ooh, looks like we got 2 of these. 3 of them? There's like 4 questions dealing with this. Now, this one is not in factored form. An intercept form is sometimes called factored form. And we haven't done a lot of practice with factoring yet. Practice a lot this year. But when you're factoring, you should always look for a greatest common factor first. And if you look, all these are divisible by 2. So we're going to factor out a 2, which would leave us with 1x squared minus 4x plus 3. And then remember when you're factoring trinomials like this, let's see, y equals 2. We're going to form two sets of parentheses here. The numbers we pick always have to multiply to c and add up to b. So factors of 3 would be 1 and 3. That's it. Now it could be positive 1, positive 3. It could be negative 1, negative 3. It could be 1 positive, 1 negative. But if they're multiplying to a positive number, they're both going to have to be the same number, same sign, either both plus or both minus. Now, they have to add up to the middle term, which is negative 4. So, do you know two positive numbers that add up to negative 4? No. They would have to both be minus. Both negative. Negative 1, negative 3. So there it is in factored form, which is how you're going to see it when you're actually practicing this yourself. So it's saying, what's a? Remember, a is the number in front, so that would make it 2. Now the p and q, it doesn't matter which one you write for p, which one you write for q. They're the intercepts, the zeros. I see it says minus 1, so I'll say my p is positive 1. I see it says x minus 3, so I'll say my q is positive 3. Again, these are the zeros, the x-intercepts. So it's going to cross at positive 1 and positive 3. Oh, yeah, so x-intercepts, you could say 1 and 3, or if you want to write those as coordinates, you could say 1, 0 and 3, 0. The axis of symmetry, if you can't figure it out in your brain, what you can always do is you can add p plus q and divide by 2. That'll help you find the middle. So if we did 1 plus 3 divided by 2, 1 plus 3 is 4, divided by 2 is 2. So that would be, the equation is x equals 2. So I like to draw an axis of symmetry, like an imaginary line. So x equals 2 would be this line here. And also, that tells you the x-coordinate of your vertex. So our vertex is going to be 2 something. How do you find the y? You substitute it in the equation and solve it. So the equation says y equals 2 times x minus 1. X is 2, 2 minus 1, times x minus 3, 2 minus 3. 2 minus 1 is 1. 2 minus 3 is negative 1. 2 times 1 is 2. Times negative 1 is negative 2. So y of the vertex is negative 2. Let's go ahead and plot that. 2, negative 2. It's right there. So that already shows you the curvature of the graph. Does that open upward or downward? Up. And you could tell that from the equation based on if a is positive. If a was negative, it opens down. Domain, we already know the domain. It's all real numbers. The range, it opens up. The vertex is the lowest point. It's the minimum point. So the lowest this goes is negative 2, and it goes forever upward towards positive infinity. Now, if you remember our steps of a normal parabola, when a is 1, the first time it goes up 1, then it goes up 3 over 1, then it goes up 5 over 1. So now we're just going to take those steps and multiply them by a. It's 2. So instead of going up 1 over 1, we're going to go up 2 over 1, which we already have those points. Then the next jump is 3. So if we multiply by 2, that'd be going up 6 and over 1. We could reflect it to the other side. Wow. Whoa. Awesome. Yes! That's how you graph. Let's try another one. This one is in factored form, which is nice. So the a is 1/2, which remember that it's positive, so that means it opens upward, but the 1/2 is going to compress it, so it's going to make it wider than a normal U-shaped graph. P and Q, we could say P is positive 6 because it says x minus 6. Q, it says x minus 4, so Q is 4. These are our x-intercepts, 6, 0, and 4, 0. Or you could just say 6 and 4, it doesn't matter. So 6, 4, Remember the axis of symmetry. The x of that, the x-coordinate for the axis of symmetry, is right in the middle of the two things. Now, again, you could add them together and divide by 2, but what's right in the middle of 4 and 6? 5. And that's also the x-coordinate of your vertex. To find the y-coordinate, you substitute that into the equation. So y equals 1/2 x 5 minus 6, and then x minus 4, 5 minus 4. 5 minus 6 is -1, 5 minus 4 is 1. -1 times 1 is -1, times 1/2 is -1/2. Or -0.5 if you'd like. So our vertex is at 5 and -1/2. Opens up, domain for everything in the quadratic unit is all real numbers. The range, the lowest it went was -1/2. And then it goes up towards positive infinity. So we have the U shape. It went up 1/2 and then over 1. The next step's up 3. But we're doing half of that because A is 1/2. Half of 3 is 1.5, so it's going to go up 1.5 and over 1. We can reflect that to the other side. The next jump is 5, but half of 5 is 2.5. So up 2.5 over 1. That'll give us enough of what we need to show the parabola's curve. Great. Hip hop hooray. All right. Whoa. All right. Consider the following form. A times x minus p times x minus q. We're going to try to write this function in intercept form. So I see that it crosses at -6 and -3. So that would be our p and q, I guess. I think the p's hiding behind this button here. -6. Q we could say is -3. It doesn't really tell us anything else, but it does tell us this coordinate. That this coordinate is -4 and -6. So the x is -4, the y is -6. Let's take this information and plug it into the general form they gave us. So it says y equals, our y is -6, equals a, we don't know. But then it says x minus p. So we'll have -4 minus p, we said was -6. And then x minus q. X is -4 minus q is -3. Let's simplify this as much as we can over here. So let's see, -6 equals a. Hey, look, when you have minus negative, it's the same as plus positive. So -4 plus 6 is 2. Over here, same thing. -4 plus 3 is -1. So this whole right side, if I multiply a times 2 times -1, that's -2a equals -6. There we could just divide both sides by -2. And that shows us 3 for a. So a is 3. So now we can use that information to write the general equation. Y equals a, 3. And look, our p was -6. So it would say x minus -6. We're going to change it to x plus 6. Same thing with the q. It said the q, the intercept was -3. So that's going to look like x plus 3. Look at us. We did it. Yeah. Let's try one more of those. Ooh. Wowza. All right, so I see our p's and q's. Mind your p's and q's. We got -6 and +1. And then the coordinate they gave us was 2, -2. 2, -2. Let's put in our information, see what we got. Y, -2 equals a. We don't know. That's what we're trying to figure out. X minus p. X is 2. Minus p, we said was -6. So 2 minus -6. We'll change it to +6 in a minute. And then x minus q, and we said q was 1. So let's clean this up a little bit. Negative 2 equals a times, again, this turns into 2 plus positive 6, which is 8. 2 minus 1 is 1. So on the right side, a times 8 times 1 is 8a. Here we're going to have to divide by the 8. Negative 2 over 8. Oh my gosh, we can simplify that. Make it negative 1/4 for a. Now we have all our information. We have our a, we have our p, and we have our q. So y equals a, negative 1/4. And then our intercepts, we had negative 6, so that would say x plus 6. And the other intercept was 1, x minus 1. Yes, 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 yes! So much fun!